My dear friends, welcome to SEKAR classes on applied data science with Python. This is lecture number 96. In this lecture, we will try to understand probability distributions. In my previous lecture, that is in lecture number 95, I completed descriptive statistics. In order to understand inferential statistics, you must have conceptual understanding on basic probability distributions. Now, we will try to understand probability distributions. Probability distributions are like 3D glasses. They allow a skilled data scientist to recognize patterns. Most of the data science skills are based on certain assumptions about the probability distributions of your data. There exists many differential probability distributions in nature. Just see this figure. If you observe carefully, there are different types of distributions. Basically, there are two categories of distributions. First one is discrete distribution, your binomial distribution and Poisson distribution, geometrical distribution, hypergeometrical distributions. All these comes under discrete distributions. I will explain what is discrete distribution in my future classes. Distributions like normal distribution, gamma distribution, beta distribution, exponential distributions comes under continuous distributions. I will discuss all these distributions with appropriate examples in my future classes. Now, what is distribution? First of all, what is distribution? What is the purpose of studying the distribution? The distribution describes the shape of the data set. Distribution gives us internal structure of the data set. Suppose there is a data set. If it follows bell-shaped curve, then I can say that data set is following normal distribution. If data set forms rectangular shape, then I can say it follows uniform distribution. I will discuss all these distributions. Just time being, understand that your data pattern may fit in one of the distribution. If it not fit in these distributions, what we have to do, we will discuss. A parameter of a distribution is a number or vector of numbers, describing some characteristics of the distribution. Parameter of a distribution is very important. I can say parameter is numerical descriptors of a distribution. So each distribution characteristics are expressed with the help of its parameters. For example, normal distribution. It's a famous distribution. I will discuss in detail about this particular distribution. Normal distribution has two parameters. Just observe this particular diagram carefully. Just let me say like this. If you observe it, this is the formula for normal distribution. Anyway, I will discuss about it. Time being, just understand that this mu and sigma square, let me say sigma. This mu comma sigma are known as parameters. Mu means sigma means standard deviation. These are parameters for this normal distributions. I can say this mu comma sigma are numerical descriptor of this normal distribution. These parameters will decide the shape of the curve, isn't it? That's what it says. So this mu comma sigma are expressed with, means I can say each distribution characteristics are expressed with the help of its parameters. Therefore, here this is normal distribution. Its characteristics are expressed with the help of mu comma sigma. Just observe mean equal 0, standard deviation equal 0.4 means you are getting this type of curve. In similar manner, you can understand all these graphs. Depending on mu and sigma value, this shape, this this particular curve is changing its shape. I can say this mu comma sigma are known as parameters of this particular normal distribution. Anyway, I will spend a lot of time on parameters. Just time being, understand these parameters are numerical descriptors of a distribution, isn't it? Let me proceed further. Why distribution? What is the purpose of distribution? This is one important question in studying distributions. In fact, some of data science models are designed to work with, let me repeat, in fact, some data science models are designed to work best under some distribution assumptions. Therefore, knowing with which distributions we are working with can help us to identify which models are best to use. Means they are useful in understanding data science models. Once if you understand model, you can apply appropriate probability distribution. Anyway, some terms maybe you may not have clarity on few terms. Certainly you will get clear cut understanding in future lectures. Just time being, let me proceed further. What distribution, let me say like this. If you know the distribution of data set, then it will help you to estimate the confidence interval for inferential statistics. That's what I told you. Inferential statistics. Anyway, in inferential statistics, there is something like confidence interval. This I will discuss what is confidence interval in my future classes. These distributions is useful. They form basis for advanced statistical methods. What are the advanced statistical methods? Statistical methods like ANOVA. I will discuss what is ANOVA in my future classes. ANOVA means analysis of variance. We will discuss different problems on ANOVA, factor analysis, cluster analysis, logistic regression. All these advanced statistical models, if you want to understand these statistical models, you must have an idea of statistical distributions. If you want to understand simulations, there is famous simulation, understanding Monte Carlo simulation. This Monte Carlo simulation is a powerful tool. I will discuss about it. If you want to understand simulation, you must have an idea of probability distributions. Even if you know, for example, if you want to simulate something, if that arrival pattern follows Poisson distribution, if you know that if that arrival pattern, there is something like queuing theory. In queuing theory, there is something like arrival pattern and service pattern. That all those things I will discuss. In order to understand, in order to model these arrival patterns, departure patterns, queuing theory, simulation applications, we need this probability distribution. Having a sound statistical background can be greatly beneficial in the daily life of a data scientist. If we are able to understand if it's present any pattern in the data distribution, we can tailor made our machine learning models, or I can say data science models, to best fit our case study. In this way, we will be able to get a better results in less time. I will continue my discussion in next lecture. In next lecture, I will try to explain what is random variable, then I will continue my discussion on probability distributions. First, we will spend enough time in understanding different probability distributions. Once if you have an idea on basic probability distributions, understanding inferential statistics is very simple. Understanding, you can model different data science problems without any difficulty. Thank you very much.